No, Wednesday class is Thursday. Final exams are next week.
No study week this time. Not study
They do.
study day.
Yeah.
Friday.
Yeah, Friday.
We didn't have like 3 days at least.
You don't need 3 days.
You did a lot this way.
Most people, I mean, look, okay, if you're a really dedicated student, yeah, okay, 3 days would be probably wonderful, but we also know what actually happens during study days. They all party the night before, and then take off a hangover the next day.
Well, if you
At my undergrad, they actually had to cancel study days because the local grocery store had record-breaking sales 3 years in a row, the day before the study day. And when I say record-breaking sales, I mean record-breaking sales of alcohol.
Yeah.
And we were a drive-in. So, just be glad that you still have it, because they took it away after that year. There's no more. And you only get in spring, technically, we get multiple because of St. Thomas Carnival.
Oh, that's like nothing gonna be a week.
Yeah, because like we'd always just meet on Monday, Tuesday. Tuesday was like the last day of classes. You'd have Wednesday was a study day, and Thursday, Friday is usually like carnival holiday. All right, it's 3 o'clock though. Well, technically 3:01. What is the characteristic of the integers? I'm trying to warn y'all. This is a note or you don't. Technically, you can calculate it.
But I have to log in. Let me tell you know in case they're coming in because things
Oh,
are.
it's zero now. You can zero now. It's all because you're from. Is it an Apple?
Yeah.
Okay, that's why. Yeah, you can get a zero now, just because you have an Apple. Actually, as I'm holding an iPad. One day I'll give you all my rant on Apple products. And it's not with the products themselves, it's with the business. All right, we're gonna get this in Zoom.
You can't hit on their success, you know?
It works. Definitely works. Cool. Thank you, Donna. All right, then we know the buttons. Does everyone have an answer in?
Yeah.
I can go here. For Carissa.
I'm gonna try it.
Yeah, you do. It's still causing issues.
Yeah, I have to have a password, but I don't even know my password thing.
Yeah. Only because it's your last daily quiz, I should write it. Voice and hold this paper. All right. So if you want to change answers, got 5 seconds. 3, 2, and 1. Locking answers now. 2 right answers. 3 right answers. 4th one. Oh, 1 wrong answer. All right, what's the characteristic? Definition of a characteristic. Let's start with that.
Smallest number in the range, smallest number such that.
It does deal with smallest positive integer, and such that, and let's say you're finishing off.
And times of equals to
Any element of the ring. So it's a number that I can multiply, a positive integer that I can multiply any other element by ring by, and I'll always get 0, which is not necessarily the integer 0. It's representing whatever my additive identity is. What's the sharing screen? So then what is that for the integers? Is there a characteristic? Or is there such n? Yeah, right? I'll never be able to multiply, let's say 1, for example, by any other positive integer and it ever becomes 0. And we said if it doesn't have such a value, then we say that that ring has characteristic 0. So the answer today is 0. So goal for today, wrap up a little bit of stuff theory on characteristic. Theory is actually pretty cool, at least what I think is a pretty cool result with them. Once I get that result, we'll talk about test, which is Wednesday, and also probably quickly about the final, since I don't have another class to talk to you after the exam, unless y'all don't mind sticking around for like 10 minutes after the test to talk about it. Or wait, do any of y'all have a class at 2? You do? You're always, no, you're not always in here, so it's night, Chris, there. Never mind. So maybe after, we'll figure it out, but if I stop talking about that, I can get through all of this. So we talked about some basic characteristics. So for Zn, the characteristic, and remember Zn is all the remainders from division by n. The characteristic of Zn was always n. Or a characteristic that will work would be n. And then, whoops. Well, so that characteristic, and then we're going to have the following theorem that we get to prove. We want to inform ourselves a little bit more about it. In part, because when we were talking about this last Monday, I mean, we had difficulty even finding just sum. And it's in part because you have to go through a calculation, you have to test every element against your guess with multiplication, and that can be time consuming. So is there a better way to get an idea of what the characteristic should be? Well, let R be a ring with unity 1. If 1, my unity element, if it has infinite order under addition, it means I'm going to be adding 1 to itself over and over again and never get back to that additive identity element 0. Then the characteristic of that ring R is 0. If my unity element 1 has order n, that is, I can add it to itself n times and I get to 0. Then the characteristic of R is that value n. And we're going to prove it. And it's actually a relatively simple proof. So we're just going to let R be a ring. With the unity 1. Is it possible for this ring to have 0 divisors? None?
Yeah.
It is, right? Do we say it was an integral domain? No. So there's the possibility of 0 divisors. We have to just kind of keep our mind open, right? There might not be any, but there's the possibility of them. Is every element in this ring a unit? No, right? So again, I gotta leave myself open to possibilities that not everything has a multiplicative inverse. All I know is I have all the 6 properties of ring and I have a unity. That's it. That's all I get to work with. Well, if one has infinite order. And there's never going to be a positive integer m. Such that n times 1, which is just adding 1 to itself however many times. There's never going to be such a positive integer that's going to make this 0. And when I talk about characteristic, it's got to be the value that works for all elements, which means it's also got to work for the unity element. So I can never find a positive integer that works for the unity element. So that means that the characteristic of this range has to be what? Yeah. So if my unity element does have infinite order, then it's straightforward that characteristic of this range has to be 0. Well, that's the case if it has infinite order, relatively easy. What's the other case? Yeah, what's the opposite of infinite order? Yeah, finite order. So if my unity element has finite order, then we know that there does exist some n the positive integer, such that n times 1 gets me back to my additive identity elements. Because again, this is just saying repeated addition. So as long as I add 1 to itself n times, then I'm going to guarantee that it's going to be equal to 0. So what we're going to do is just pull an arbitrary element from the ring and consider that arbitrary element times the order of my unity, or n times x. Which means, we had a couple different ways to look at this, but I'm really just adding together x how many times? And each of those terms in that summation have a common factor of what? X. Or I could think of it as each of those has a nice little multiplication by my unity element 1. Because x times 1 would be equal to x. So I can take advantage of that left distributive property and rewrite this as x times just a summation of 1s. How many summations of 1 do I have there? N times. And wait a second. If I add my unity element 1 to itself n times, what is it going to result in?
What?
If I add my unity element to itself n times, what is it resulting in under our assumptions? 0, because that would be the order of that element. Which means that this is x times 0. But one of the properties in rings, 0, my additive identity times anything else is always going to result in what? Yeah, it's nice on top of me today. Thank you. And what have we just shown?
And any number with you.
So I wouldn't say any number, because we're not thinking like integers or anything. Where did x come from?
R.
And ring, right? So any ring element times n is equal to 0. Doesn't matter what that ring element is. Therefore, the characteristic of this ring has to be what? Not zero. That's. If you want to send this. Yes. Save or reuse, whatever. Then what is this theorem essentially telling us? If I want to find the characteristic of a ring, I really just need to determine the order of what element. The unit. That's it.
Oh,
I don't need to go investigate every single element, see if I make sure if I multiply it by this particular positive integer that it will always result in my additive inverse. I just need to investigate the unity element. What's the order of the unity element? And that becomes the characteristic of the ring. And we have shown why that's the case.
If every element is a unity, then it just. Yeah,
Well, you wouldn't have every element in unity because unity is what? It's unique. It's unique. That was one of the things you have to prove. So there's one and only one. What are the questions I got? And then big theorem. Last theorem for class. What's that thinking? We've done so much. Function of a ring of an ideal or integral domain. We'll die in this minute. The characteristic of any integral domain will always be zero, either zero or a prime number. Characteristic of any integral domain is either zero or prime. What is the definition of an integral domain?
it has a constant property.
Yes,
It has no really like
and it's what has no zero divisors.
the integral.
It's a ring. Unit of ring. And it has what other element, and then we add on the no zero divisors with unity. It's a ring, commutative ring with unity and no zero divisors. So as long as all those are satisfied, your characteristic is either zero or five. We're gonna let R be an integral domain. And just make a note, what we're gonna refer to as our unity will just still be one. And the previous theorem has already done a lot of work. Because we just said as long as it's a ring with unity, it doesn't have to be an integral domain. It's a ring with unity, characteristic is always zero or whatever the order is of my unity, right? Which we refer to as N in the proofs. So I don't have to kind of consider the zero case, right? Because we know it's zero from before if the order is of the unity element zero, or is infinite. So we kind of get the zero case for proof, which really just means I got to go back to that and say, all right, well, if I do have a finite characteristic, well, then that finite number needs to be what type of number? This needs to be prime. That's all we need to show. By the previous theorem, need to show is that the characteristic of my integral domain is finite. And it is prime. There's a 0 and 0. Nothing interesting. So this is the statement I need to actually prove. What other assumption do I get to make? What was the statement we just said we actually, that's all we really need to show?
If you know that, and it's fine.
Yeah. If it's finite, then it's prime. So I get to assume what about my characteristic? It's finite. And then from that deduce that it has to be a prime number. And if the characteristic is finite, then I can just also deduce that the order of my unity element is what?
Right?
Is going to be that finite value for the characteristic. So let's order of my unity element be a positive integer. And is it easy to show something as a prime number? How do you show n as a prime number?
It's already.
One in itself, but what information do I know about the divisors of n? All I know is it's a positive integer. I don't really have much context other than maybe, okay, I take n times 1, it's got to be equal to 0. That might give me a little bit more information, but that's not going to give me any information about the visibility effect. So if I run into these situations where I can't hack an object head on, there's a proof technique that we always employ. What's going to help? Contradiction. So we're going to assume then, okay, it does have finite order, but it's actually a composite number. Yeah, composite number. Assume for contradiction. That n is not a prime number. Then that means there exists two positive integers, which I'm just going to refer to as p and q. And so that's all correct. There's one important thing about p and q. They have to be between 1 and n. Essentially, I can factor. And the factors aren't just one itself. Does everyone see that? Perfect.
I just want to make sure that there's a power between.
Yes, that is fine. That's why I could write about it. We rewrite. A little there. All right. Well, if the order of my unity element is this n, then I know 0 is equal to 1 times the value of n. Because of this assumption for contradiction, I'm assuming n is composite, so how can I rewrite that? Mhm. So it's my unity elements being added together, p times p times. But I can rewrite this expression, take advantage of the fact that this is integral domain, and from that get my contradiction. Because think even as Sinai pointed out earlier, we have no zero divisors. What does that also imply? Get what particular property, desirable property. We have no zero divisors, we get what desirable property.
It's not field.
Not fields. So fields are technically integral domains, sorry. Cancellation we get with, field, we get integral domains, I can't remember, I think we got integral domains. No, because we need units. Gotta go back, that's not what I'm looking for though. The zero property. A times B is equal to 0 only if. Yeah, one of them is 0, right? That was the nice thing about integral domains, is it gave us that property. That's what we care about, studying that particular type of structure. So maybe I can take advantage of that. So I can rewrite this as my unity element times B multiplied by unity element times Q. And since I'm in an integral domain, I know that one of those two values, 1 times P or 1 times Q, it has to be what? 0. What's the issue here? Mhm. So it's not with our argument that we're making, we finally hit our contradiction. What is it?
It's not me. But either P or Q.
So one of these two multiplications that we do, right? 1 times P or 1 times Q is going to be equal to 0, which means the order of my unity elements what? 0.
And
Well, that's what we started with.
P or Q.
And what we've now deduced is if n is composite, if I can actually factor it down into two numbers, then really that order has got to be either P or Q. And that's creating an issue with just the idea of what order is. Order is the smallest positive integer of when I can take this element and add it to itself as that many times, I get back the additive identity. And this is why I make sure to rewrite P and Q are both strictly less than what F. Less than N. So if I can take 1 multiply it by a value less than N and equals 0, or 1 times the value of Q and it equals 0, both of them are less than N. The order of my unity elements here at Q less than N. Create a contradiction with the definition of the order of an element. So we assume, oh, you have a question? Go for it.
Yeah, okay, so I'm just a little lost a little bit, so the issue is that, with the whole with the range of it. Is that it's supposed to be between 1 and 10, but like the 0, that's the issue that we're talking about.
No, thank you for asking. So, what does it mean to be the order of an element? That's where the contradiction is coming from. So if I don't remember that, then it's gonna be hard to spot the contradiction.
That was it.
So the order of an element, this is going back to our groups. Order of an element X is the smallest positive integer such that X raised to whatever that integer is was equal to whatever the identity element is. Now, when we're talking about with rings, our operation in this case is addition. So really what I'm talking about, so this is in groups. I was just considering groups alone. One operation, which we always just call multiplication, with quotes around it always in our head. But when it goes to rings, right? If I have a ring, inside of it is a group under which operation?
I think,
With an addition, right? If we go back to our definition of rings, essentially say form a group with addition, and then add on two properties with multiplication, your second operation. So in this case, when it goes to a ring, it changes up a little bit. You're good. Hold on a moment. Gives me a chance to take a sip of water as well. Anyway, so you're good. So inside of a ring, when I see n times x, I'm just thinking of taking x and adding it to itself n times. So that I'm adding, which is my operation here, it's going to be equal to my identity element per addition, which is always represented as 0 in a ring. But the key is, it's got to be the smallest positive. We claim at the start, we get the order to be finite. And then say, well, actually, no, there's something less. Which means n couldn't have actually been the order, which is what makes the contradiction. So to get that contradiction, we assumed that n was composite. And that caused an issue, which means then the order of my unity has to be what? Yep. And if the order of my unity elements prime, then I know the characteristic of this integral domain is also what? Characteristic of my integral domain is prime. Argument's done because we had an order for a unity element, got to be prime in integral domain. And if it's 0, okay, cool. What questions y'all have? Well, that's it for material and abstract algebra. Sorry I didn't get us to Chinese remainder theorem. I'm like 2 lectures away from Chinese remainder, which is cool because we needed to find ideals of rings and factor ideals. Once we had factor ideals, we could do Chinese remainder theorem. We were close. But I got pretty much everything, at least in the course catalog description, which is good. So now you're familiar with all this stuff, so if you go on grad school or you decide to take abstract algebra 2, we'll know we're gonna start off at. So, y'all ready to transition talking about the test, or not tomorrow, Wednesday?
Mhm.
All right. So 50 minutes in person. Only thing that you're gonna need to bring is I'll let you have a scientific calculator if you want. I mean, I haven't written the test. I don't see why you would need one. But you're welcome to bring one, pencil, and I will provide scratch paper. The test is going to kind of be in 3 portions. So the first portion is going to be definitions. So you need to be able to write out the definitions of things like, what does it mean to be an integral domain? What does it mean to be a ring? What is the order of an element? What is the order of a group? All the different definitions that we have made or defined in class throughout the semester is fair game.
The whole semester.
Oh, sorry. Technically, yeah, for just the last midterm. For the final exam, it'll be similar, but that one will be. This one is just since the last one, which is. I don't even remember.
Homework time.
Yeah. I think we're still,
Homework.
yeah, isomorphisms would be here. The homomorphisms, I don't think that showed up on the test. Actually, I can look. Don't look behind the curtain, everyone.
Cycles.
Where's midterm? I just want to look at the midterm. Right. Yeah. So it goes up to order. So we talked about order centralizers. All right, so pretty much anything after that. You can also go back. Remember, I'm posting all these lectures. So our test was what due. We just saw October 6th. So any lecture that starts after October 6th is any material in there is going to be fair game. So that's going to be the first third. Second third is going to be, I'm going to get you to recreate one of the groups that we've done in class. So like, for example, I could give you this theorem and say prove it, right? It's not necessarily something that's brand new, it's something you've seen before. And I expect you to just have it memorized and be like, well, not memorize word for word, but at least you can remake that argument. So I don't expect to, if I ask this to be on the test, I don't want a word for word copy, nor do I expect a word for word copy of what we have. But you should be able to recreate it because you understood the proof, you understood what was happening, you understood the steps, right? I remember what I started with. I remember we assumed this and then made a contradiction argument. And this is where we got the contradiction. That's how I got the result, and I can recreate it in a text very quickly. Does that make sense?
What's going to be your criteria when choosing?
Whatever I choose. I mean, I'm not gonna give you one, I don't even think we have one though, like, unless we go way back to beginning of the semester, it's gonna be like 2 pages long or something. That's just not gonna be reasonable for a test, 50-minute test, but shorter ones like this that are really just a paragraph or 2, absolutely fair game. Maybe even 3 paragraphs, 4 paragraphs, depending on how much you wrote. And then last third is gonna be technically new proofs or a new group, 1 or 2 maybe. I'm going to try to keep it close to either homework problems or something that I feel like you should be able to very easily deduce in a short amount of time. Right, so it's not going to be like one of these proofs where there's like 5 or 6, 7 steps. Maybe you have to rewrite expression to get the result. You know, as we saw for rings, maybe add in the right 0, things like that. But that's only going to be a third of the text.
When you say new proofs, you talking about like stuff that we recently did, you talking about like a proof that you're creating that you have to like.
Yeah, so I'm going to give you a statement and then and during the test, you have to prove it.
Okay, it's not necessarily meaning like you on the material.
Yeah, no, I'm not gonna give you like the new definition. Terms like I've kind of done in homework sometimes, like let's say kernel, for example. I'm not gonna give that to you and say, here's this new definition, I'll play around. It'll be on stuff you've done before. Now, technically, you know what a kernel is, so you can do a test problem on it. When it comes to it, so maybe you gave me a great idea. You're regretting it? You're regretting it now?
Yeah.
No, the point is like. What, on this. Midterm. Like you can even see here, I quickly sketched it out. Like it was just quick rewriting and we were done. I know probably when you had a lot of free time, thought about it a lot more, probably overthought it a little bit. Right? But a proof like that, I feel will be fair game for something that can show up on the test. Now, something for let's see, number 3, right here. That one itself might be a little bit too much to add on when I'm guessing either states and definitions and rewrite proof of another theorem. Because ideally it should be like 20 minutes for the first 2/3, right? You know enough definition or you don't. So you write it out, you're done. Proof that you've seen in class before. You write it out, you might have to re-remember, re-figure out 1 or 2 portions of it, but you pretty much know it shouldn't take you more than 10 minutes to do, and then you have 30 minutes to think of a proof for something. So like maybe number 3 might be too much, but that last one that we saw on the last midterm, that could definitely show up. This is just to give you ideas. Because one of the best things you can do when studying for a math test, especially at this level, is to say what questions might be asked, write them out and answer. That's true for pretty much any class, even if it's in intermediate calc 1, 2, what else would you in this semester? The math classes you'll have. Probability, like anything like Dr. Parr. What questions would he ask me about specific distributions? And then, you ask the question and then you go find the answer and write the answer, whatever you need to do. And that's a great way to start studying for this because you'll start to find a lot of nuances that I might want you to pick up on a test. Help you greatly if you've already discovered. Okay, so again, 1/3 definitions, 1/3 theorem that you've already seen before that we've done in class, and then 1/3 of technically new things, might be related to homework problems, or just concepts related to a proof we've done in class. So, do you kind of understand the general idea? Cool. Knowing all of that, what questions do you have? And Shanika, don't be afraid to speak up if you have questions.
I have a question about homomorphism.
Okay.
If C of A times B
Mhm.
is equal to C of A times B.
Yeah.
Well, I was saying that we do with addition, or like you got no.
So there are ring homomorphisms. A ring homomorphism, same concept, you have to do it for both operations. So when we defined homomorphism and isomorphism, it's only in the context of groups. So if it, let's say, shows up on a test, it will only be in the context of groups. That's it.
Yeah,
Okay.
well,
But there is homomorphisms for rings.
not for ring though, like in groups area, they were using like addition.
It depends on if the operation was defined explicitly. Right, if we're talking about a general ring, we always say multiplication just as to represent the operation. But, I could say my group is integers with addition. Right? So whenever I say G is a group, let me write this out. your homomorphism definition was. B of, let's say it this way, A operated with B is equal to B of A operated with B of B. So I've now explicitly told you what your operation is. It's normal standard addition. So then how does that notation get rewritten once I know exactly what my operation is? It'd be still the same concept, right? B of A operated with B, got to be equal to B of A operated with B of B. You just probably only use addition in that specific instance because you're given that as our operation.
Okay, thank you.
What other questions I got?
So besides the definition, we have some other theorem and what's that called? Do you memorize as well?
Properties, like that'd be a great question to ask. What are the 6 properties of being a ring? Right, I might give you all the preamble, might still be helpful to know all the preamble. But
What is the preamble? Sorry, what is the preamble?
all the stuff leading up to the 6 properties.
Oh,
Like, let R be a set of 2 binary operations called addition and multiplication. And then a ring is a set with these 2 not binary operations where the following properties hold. Then you list out all the properties. And you probably have like up there, like, let A, B, and C be elements of the set. Right, that's a lot of preamble. So I might ask you for it as well, or I might just ask you to state 6 properties.
It's my memorization.
Yeah.
We're not great.
To memorize the theorem, all the theorems too, right?
You would want to. I mean, I don't think I'm gonna quiz you because we don't have great references to specific theorems. Like, maybe if it was earlier in the semester, I could be like, okay, we talked about Fermat's little theorem. We named it Fermat's little theorem in our notes. So then I would expect you to understand if I say okay, state Fermat's little theorem, then I would expect you to give me the statement. But for what I'm talking about in the test, the statement, I'll give it to you. You just need to remember the proof of the statement. So you don't need to memorize all the statements of every theorem word for word to be able to just regurgitate onto a test, but they still might be helpful, right? If I was asking to find characteristic of a particular lane, right, rather than you have to go through and calculate positive integer operated with everything, I know to look at, okay, is it an integral limit? Okay, well, it's not just what's the order of the unity element. So first find the unity element if it has one, then look at that and gives me the characteristic, right? And I'll still need all that information that the theorems provide for me, but I might not need to know it word for word with statements. Yeah. No? Okay. All right, what else?
can we go over time? Like, you don't allow us to like 10 minutes, 20 minutes over time?
I want to get out of here. My last day of classes too. I mean, look, when I write this, the goal is to make it 15 minutes. I usually shoot for 40. Because a good rule of thumb that I use for test writing is however long it takes, I give you 4 times. So whenever I write a test, I can't complete it in 12 minutes, then that's too long, in my opinion. So it's going to be designed where you can do it in 50 minutes. Okay. You shouldn't need extra time. All right. What other questions? So if I think of anything else I want to add to all of this, then I'll make sure it's posted in the Blackboard announcement. I'll send out another reminder tomorrow, just make sure it's up there. So just keep an eye out for Blackboard for any small updates, things like that about the test, okay? And final is probably gonna be the same way. Where like a third of it's definitions, third of it is gonna be theorems that you should have, proofs you should have memorized. And then the last third would be just some new proofs, maybe rewritten school homework problems, things like that. Just in case we don't get time to talk about it all. Right? Well, good luck studying. On Wednesday, if you have any questions, I've got office hours tomorrow morning. I'll be here for a little bit in the afternoon, but I don't guarantee I'll have free time in the afternoon. Or you can just send me an email.
Okay, Dr. Thank you.
All right, you're welcome.